Hello, assalamu alaikum, greetings and good day. Welcome to Learning Economics and also welcome to our series Data Analysis using R. Today we shall talk about string or character variables. Viewers, as you already know that we have used these strings multiple times, but in today's lecture we shall dive deep into these variables and see what wonderful things we can do with these variables. And for that, we shall use stringer package. And stringer package can be downloaded separately, but it is also a part of the larger package tidyverse. So we shall use it from the tidyverse and shall see on the screen of RStudio what can be done with this string variable. However, before that, if you have not subscribed to this channel yet, I request you to please subscribe to this channel, share your feedback in comments, and share our videos with your friends and fellows if you really find them helpful. So over to RStudio screen. So let's load package tidyverse to the library. You can see the stringer package over here. So let's start with creating strings or creating character variables first. As you have already seen that we have been creating these variables by putting some numerical value or some alphabets within the inverted commas. So following that, this is how we create a string variable. We put anything like ABC in inverted commas and R classifies it as a string variable or as character. We can view the objects of this string by using str underscore view. And we put in x1 and here we have all the characters of this string. Similarly, we can put any numerical values as well, but for that too we need to put those within inverted commas so that R could classify them as string or as character variables. And for again for the entries in this string, you need to use str underscore view function. However, if I need to put a sentence, for example, uh, Pakistan is my country, I can also do that in a very similar way. For example, x3 is, I create this and I say Pakistan is my country. And now if I use this string underscore view and say it to show me x3, it is showing me that this is the content of this string. However, if I need to put somebody's else answer to this question, for example, what's your country, in his own word, I need to put it like he told England is my country, or she told India is my country. So in this case, you need to put inverted commas within that sentence, and the whole sentence is to be recorded as a string. So what should we do in such cases? In such and all other cases as well, we can use single commas instead of double inverted commas. For example, if I say, for example, x4 and I save it as string, I need to put, for example, A, for example, ABC, for example, 1, 2, 3. And if I ask or about the class of this x4, it will say it's a character. And if I use str underscore view x4, it will give me all the values within this string vector. Similarly, for example, I create this country and I use single inverted commas and I say he replied, for example, UK is my country. And then we close this and you can see this is exactly saved as this, and we can view the class of it, class country, sorry, spell mistake, and it's saying it is character. And if I use str underscore view and then I write the country, it is showing me the complete string. By the way, all the functions that work on string data or string variables or character variables start with str underscore. So this makes it easier to apply any function, because as you type str underscore, R populates a list of functions and you can select either any of them, and you can select either function from this list, or you can keep on typing and it will keep on filtering the list. So this makes it very easy to apply some functions specifically designed for string variables. Now we shall create string. Now we shall learn about creating strings from other strings. This will help us solve many common problems where we have some text we wrote, and that text we want it to combine with the strings from any data frame. For example, uh, you have a good online store with thousands of customers, but 10,000 customers are your regular customers. They shop very often from your store, and you want to send them a greeting message. You have stored their name, all of their names in a data frame, and you want to send them a message. Hi, John. Hi, Maria. Hi, anyone, and then say, thanks for choosing our store for your shopping. We look forward to welcoming you again, or such message. Then it becomes very tedious and very difficult to write such customized messages or such customized greetings for everyone separately. But using these functions, which I'm going to discuss, it becomes such an easy and it becomes such an easy job, and it saves a lot of our time. How we can do that? We can do this using str underscore c and str underscore glue functions. And we can use them with mutate as well. First, str underscore c. str underscore c takes any number of vectors as argument and returns a character vector. For example, if I write str underscore c and then I write, for example, A, B, and C, it combines all of them and returns to one single character, which is ABC. And this is also a string. Now coming to the problem that I asked you as a question. Suppose we want to write hello followed by the name of the person to whom we want to say hello. We can do so using str underscore c in a way like, for example, we say hello and we want to combine it with the names. So the vector of the names is, for example, John, for example, David, for example, mm, Nana, for example, 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 mana. Just let me put it within this. So what it will do, just see the wonders. It says, hello John, hello David, hello Nana, and hello Mana. This is how you can create string of the messages, customized messages for the people with their own their name. But here we see that there is no space between hello and John, hello and David, etc. So how can we do that? We can either add a space here, works perfectly, or we can add a space before the names of these persons. But for that, we need to add the space before the name of everyone. So now again, it says, hello John, hello David, hello Nana, hello Mena. So this is how we can create messages for our online stores, for our friends, for our relatives, for anyone else using ours, this function. And this exactly applies to the data frame as well. So, and it works with the mutate as I already told you, following the usual rules of recycling and propagating missing values, etc. So for example, let's create a table formed data frame named as DF, and we use because we are creating it in a table form, so we will use table function. I will explain this table function to you later. We put the names of these persons as, for example, David, and for example, Mana, for example, Nana, and for example, John. So what we did, we created a data frame. You can see it over here. We can view it as well. View DF, and here is the data frame. Name is actually the name of the column. We can put anything here as column's name. And these David, Mena, Nana, John are the entries in this column. So now if we want to uh, use the mutate function for creating such a message, for example, we can use this like df and followed by the pipe function. We can use, for example, mutate, and in the mutate we can say it to create a greeting, for example, which should be created using str underscore c, and we write, for example, I write hello followed by space, then I write the name of that column from which it needs to pick those entries to be combined with hello, and followed by the following message, which should be followed by the name. So I'm just putting this mark over here. Let's see what it does. It says, hello David, hello Mena, hello Nana, hello John. So you can put any message over here at the place of this sign of exclamation, and it will combine all this into one. Now you may think that using str underscore c is really cool, but when you need to create longer strings, then you may mix up with those commas and other punctuations. For resolving this issue, str underscore glue is a very handy function. It actually allows us to write the string in a manner we want to display, and it allows us to place the placeholders where we want it to be combined with any list. For it's getting some difficult, I can understand, but it's really very easy to do. Let me go to the RStudio screen again, and let me explain there what I really want to say you what I really want you to learn. So here uh, we can do exactly in same manner, but we can do it like here. We can do it like this. So from this data frame df, sorry, we are using mutate, and within mutate we want it to create a message, let's say greetings this time, and instead of str underscore c I want to use str underscore glue. Now I want to write this string as hi followed by the name from this name data frame and followed by the message. So I will write it hi. Here I need to insert the name. So I will insert the placeholder with the name of the column from which it needs to pick up the values, followed by sign of exclamation. So again, so here, if I just write it, it produces hi David, hi Mena, hi Nana, hi John. So this is how this str underscore glue makes our job very easy, and it makes our job even more easier when we need to add multiple sort of information. But you can store all that information in various columns, and then where you want the information from that column to be inserted in the column, you need to put a placeholder within curly brackets having the name of the column. It will pick the value from that column and place it there. Or if I create another data frame, let's say df1, uh, I am creating it using this tibble function, but I am now creating this as a two column vector. So for the first column, I am writing the cities such as city equal to, for example, Lahore, for example, Aligarh, for example, London, for example, Nairobi, and followed by the second column, which has the name of the countries to which these city belong to. So for that, we put in the first as Pakistan, the second as India, the third as UK, and the fourth as Kenya. Uh, I am sorry for my spellings, but let's just make it. So it has created, let's view it, view TF1. So this is the city and this is the country, and using the uh, glue function, we can work like this TF1, and we say it to mutate and mutate into an information, for example, in which we want to use it str underscore glue function, and it says I belong to, this is where I want the city name to be. So this is the placeholder for the city name, which is a part of, yeah, which is located in, for example, here I want to insert the country. Oh, sorry. Oops. just need to close. Yeah, and yes. So it says, I belong to Lahore, which is located in Pakistan. I belong to Aligarh, which is located in India, London in UK, and Nairobi in Kenya. So this is how we can use str underscore glue, insert placeholders, and create the customized messages or customized email, etc. Now the third function that we are going to learn is str underscore flatten. Where str underscore c and str underscore glue work well with mutate because the output is of the same length as of their inputs. What if we want a function that works well with, say, summarize, that always return a single string? That's the job of str underscore flatten. It takes character vector and combine each element of those vectors into a single string. For example, if I use str underscore flatten and create a column having entries such as A, B, C, D, E, F, G, H, it returns me with a single string A, B, C, D, E, F, G, H, I, combining all these entries. And if I say no, I want to combine these entries, but they must be separated by, say, comma. How I can do that? I can easily do that with string underscore flatten. As I write, for example, I am creating a smaller string this time, for example, X, Y, and Z. I should get out of this vector and then I should give the separator or the delimiter which separates these values within inverted commas. So I have given the comma in it. So it returns X comma Y comma Z. But I want these to have a space within them as well. So I can add a space over here. So it will add space and comma, or I can add space after this comma. So it will return me X comma then space Y comma then space Z. How if I want to write anything before the last or before the first number, say, for example, I want it to return to me as X comma Y comma and Z. This is how we actually write those sentences. So for that as well, let me go into this previous and I would just add, then I will add last is equal to, and here how I want last to appear. I have added a comma, space, and then space for the last. So it will add X comma Y space sorry, X comma space Y comma space. This is because I have added the space after this comma here. And here this space actually this comma followed by this space followed by and followed by this space is actually because how I wrote it. I wrote it exactly in similar way, comma then space then and then space and then ended. So it returned me in exactly the same way. Now let's talk about extracting some data from a string. It is very common for multiple variables to be joined or crammed together in a single string. For example, many times in household surveys, countrywide household surveys, we have a string number, say 10110103. This number combines a code for district, a code for family, a code for rural area or urban area, and so on and so on. But we need to separate this information. So we need to extract all that information from the string. How we can do this? We can do this using these four functions. If you look at these closely, you see there is a common pattern here. It starts with separate underscore, then longer or wider, followed by underscore, then dealing or position. That is because these four functions are composed of two simpler primitives. First, underscore longer function makes input data frame longer by creating new rows, whereas underscore wider function makes input data frame wider by generating new columns. Similarly, dealing splits a string with reference to a delimiter like comma or dash or space, whereas position splits at specified width like number 2, number 3, number 4, number 5, number 1, etc. Let's work with this so that we can understand more about this. Let's create a new data frame uh, and let's name it like df2. So we are creating df2 using tibble function, and here we say that the column has entries. For example, first entry is A, B, C. Second entry is T and E, and third entry is say F only. Maybe need to give the name to this as well. So let's give the name X to this. And this closes this bracket, this closes this bracket. I think there should be no issue. Yeah, df2 has been created. So let's view this data frame. Yes, X, A, B, C, D, E, F. Entries are separated by comma. So use longer and delimiter to work. So we use, for example, df2 using this pipe function. Separate underscore longer underscore delim. Here we need to give the name of the column in which we are interested. This name is X, and then we are using delim, and we are giving this delimiter within the inverted commas. So let's see what it returns to. It returns to A, B, C in 3 rows, then followed by D, E, F, followed, and this actually makes a total of 6 rows, whereas the original data frame had 3 rows. So it had actually made this data frame longer. And if I have another data frame, let's say df22, where I have A space B space C, then I have D space E, and then F space G, for example. Let me view this df22, and here we have space. So following the initial denomination, what we can actually use here, instead of this comma, we need to use this space. Name is again X, so we do not need to change. So it's returns to, oh sorry, I should have used df22 data frame for this reference, but we have made a mistake, but no harm in analyzing what's the output. So it searched for this space to delimitate these strings, and since there is no space in df2, so it has kept it like the same. So ABC, DE, and F. So no it had made no change because it failed to find the delimiter. Let's make this correction. So here, and we need to give the data frame as df22. What it does now, it returns A, B, C, D, E, F, G. So it exactly works in exactly the same way. If I change my data frame and df22 to say A, comma, space B, comma, space C, then D, comma, and F, comma, it has saved it as a new. And just let me close it, and now let me view it for you. So here it is. Now if I use the same only space as delimiter, what will happen? It will delimit from the space it sees, not from the comma. So A, comma, B, comma, C, D, comma, E, F, comma, G. And if I use the only comma as a delimiter, it will keep the space. So it has A, B having some space, C having a space, D, then E having space, and G having space. But if I want to do it in exactly the way it should be, I should add comma and a space. Now it will do it in a very good way. So this is the output. Now, if we use with instead of dealing, how we can do that? For example, let's create another data frame df3 this time, and we use that the same table function. We give it name, for example, y, which is equal to a column of let's say one, one, two, three, four. Let's say 4, 3, 2. Let's say 0, 9, 8, 4. Okay. So we created this data frame. Let's view it first. So this is the data frame before us. And let's say this time we want to delimitate it using its position. Then how can we do that? We can do that using df3, and we can use separate longer position. Here first we need to give the name. Our name is this time y, and then we need to tell it the width. For example, if I say 1, so it has separated it 1 separate, then 2 separate, then 3, then 4, then 4, 3, 2, 0, 9, 8, 4. If I change the width to say 2, what it will do, it will pick up the two numbers. For example, from this 1, 2 followed by 3, 4, then from 4, 3, this 2 will not be combined with the next, so it appears separately, and then 0, 9, and then 8, 4. This is how you can use this longer along with width or with position. Now, if we need to separate into columns, we can use this width function, which will add new columns. And this tends to be more useful when there are fixed number of components in each string, and we want to spread them into columns. However, this is slightly more complicated than longer, because we will be creating additional columns. So we should give the name. So we must provide the names of those additional columns as well. That let's create a new data frame. This time I am pasting it to save the time. Let's say the first number shows the code, second number shows the addition, and third number shows the year. So this is the code, this is the addition, and this is the year. Let's view it. Yeah, it's created exactly like that. Now we will be separating it using the divider, and first we shall use delim. So I would say, so I would start using df4 followed by this pipe function, and I would say separate wider delim. Here I first need to give the name of the column. Column name is this type X. Then I need to give the delim, to give the name of the column, the X. Then I need to tell it either to use a delim or width. I am telling it to use delim, and my delim or delimiter is this dot symbol. I also need to give it the names of those new columns that will be created as a result of that. And since these are the three, so I need to provide three names. And for that, I will use name equal to C, and then I will write the name. For example, code followed by addition followed by year. So yeah. Oh, there is some error, and let's read it. It says problematic argument is name. Oh, I should use names instead of name. And you can see when you write the names, it pops up. Yes, you are right. So it has created code, separated A10, B10, 15, and then ED1 to 1, and then year. Now for the position, let me create another data frame. This time I am naming it as df5. Let me omit all these. So I'm just copying that. So I'm creating df5 variable name. Let's change it to C, for example, and these are the entries. So let's view. Yes. So now I want it to separate as per position. For that, I need to, I need to, for that, just let me give the reference of the data set first. So this is the reference of the data set, and using the pipe function, we are asking it to separate with position. And here we need to give the name of the column. Column name is this time Y. And because I want to separate it for the position, and while using the position, you need to give the width value. So I am writing width widths, and I am saying it that widths are such that, for example, 2022 is year. So I say year is equal to 4. That means first four values to be recorded as year. Then 1512 or 25. Let's call it as age. So I say age is equal to 2. That is first four, then next two, and then last two are for state, and I say state is equal to next two, and it seems everything seems fine. So, oh sorry, The column name was Z actually, so just need to put that Z. So the year is here, the age is here, and the state is here. Is how you can use those delimiters. Now, in the last part of our this lecture, let's talk about individual letters within string and learn how to find the length of the string, extract a substring, and handle long strings in plots and tables. So to get the length of any string, we use str underscore length function. For example, str underscore length, and I give it a column. Say this is A, this is learning economics, this is data analysis using R, and say this is and say there is something NA. So let's see what it returns to. The length of A is 1. The length of learning economics is 18. Let's count 1, 2, 3, 4, 5, 6, 7, 8, space 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it counts space as well. You can count yourself for data analysis using R. Since NA is an entry which has missing value, so it returns to NA. Extract a substring, we can use the function str underscore sub. For example, let's create a data frame, but let's call it X this time. And we have a vector. In fact, it is apple, banana, let's say mango, let's say toy. So where it went? So it is apple, banana, mango, toy, etc. All these things. Or we can also view it apple, banana, mango, and toy. But we want to extract, then what we say it to, and if we want to extract a part, we use this function str underscore sub. We give the name, which is X, and we say, let's say 1 and 3. It will actually start extracting from the first letter and will extract up till third letter. So this is 1 and 3. So A double P from it, BAN from it, MAN from this, and TOY from this. Let's say we add another argument to it, let's say OR, and let's view X this time, and it has more. So let's apply the same substring, and we know that in the last component of the string we have only 2 letters, but we are saying it to extract from the first till the third letter what it responds to. It has extracted first 2 letters and done its job because the third one was not available. So it has not returned to NA. This is important. Only missing value will return to NA. Otherwise, most of the functions that are words will be carried out using the best possible option available. And if I am to extract from the other side, that is from the last letters, I can add minus sign. For example, I say from -2, or let's say -3 to -1. So it has extracted. This is -3, -2, and -1. This is -3, -2, again -1 not found, but it has not returned to NA. So this is all about strings or character variables. So that's all for today's lecture. In the next lecture, we will cover some other topics. Do subscribe to our channel, give a thumbs up, take care, and bye-bye.